Okay. So in the last section, we did correlation, R values. We did all those big tables with the sum of X and sum of Y and sum of XY and so on and so forth. We're going to take it a step further now and use a lot of that same information to do linear regression, which is lines of best fit, which is slope and Y-intercept that we calculated with the calculator. If you remember doing that a couple days ago, we're going to learn to do that by hand today. Okay, so a couple things on your paper first. So line of best fit, its official name is a regression line. So you might see it referred to as both ways. The best line that we can create with this regression line is one that has the least amount of residual. Okay, residual is a difference between a point in our data and a point directly above or below that point on the line. So pretty much we want to minimize these distances the best we can. And ideally, we want our line to hit every single point if we can. If not, we want it to hit as many points or in the middle of those lines as possible. When you calculate a residual, the formula is actually here at the bottom. It's an observed value of Y. So when we say observed value, that's the actual data from your set. Minus a predicted value of Y. And a predicted value of Y is going to come from your actual Y equals mx plus b equation that we'll calculate. So we'll practice that in a little bit. A residual could be positive or negative. A positive residual tells us that our point is above the line that we're estimating with. A negative residual tells us that we're below the line that we're estimating with. Okay, the next slide on your paper is just a quick little matching, and we'll do this together. So we have some regression lines graphed over their respective scatter plots. We want to match the equation with these. So it's a little review of just algebra 1. Y equals mx plus b. Remember, if we have y equals mx plus b and we use what's called a y hat, we'll see that in a minute. It's got like a little, I don't know, almost looks like that exponent key in your calculator above it. Y equals mx plus b. B is the y-intercept, so it's where it's touching the y-axis. M is our slope, or our rise over our run. These lines are not actually touching the y-axis, so what I would recommend on your paper is just to, the best you can, kind of sketch those lines, extend them a little bit so you can see that y-intercept. It's going to make the matching piece a little bit easier. Oh, don't do that. There we go, something like that. Okay. All right. So letter A, does it have a positive or a negative slope? Negative. It has a negative slope because it's going down. So that narrows it down to the first one on the top left or the bottom right. And then we can look at the y-intercept from there. So is my y-intercept at about 21 or about 27? It's about at 27. So that bottom right one is going to match graph A. Graph B then, what would you say that guy is?
Negative. Oh.
It's a negative slope again, and we only actually have one other one with a negative slope. Y-intercept, maybe about 22. Letters C and D are both positive slopes. So again, we can just look at the y-intercept. Letter C looks like it's around 20, maybe like right there. And then letter D is maybe around 10, so something like that. Okay, so quick little match and nothing crazy. Questions there? Easy enough. Okay, calculating the regression line, like I said, we're going to use y hat. When you see the little hat, that's for a predicted value of y. It's not an exact value of y. Okay, that's why we use that instead of just the y itself. Two formulas you need are M, which is this guy, and you notice it looks really similar to everything we had in that R formula a couple days ago. So we don't have as many columns. We don't need the y squared column, but everything else we're going to need. And again, is the number of pairs of points that you have. And then B does have its own formula. Truly, though, I think this is the easiest one to use for it. You take your mean of your x data and the mean of your y data, which you'll already have the sum of your x's and the sum of your y's from your table, and you're pretty much just plugging them into y equals mx plus b. If I take my y equals mx plus b equation and I solve for b, it's y hat minus mx equals b, which is exactly pretty much what you have here. but instead of plugging a full point in, we're plugging the mean of our x and the mean of our y in. What you see under the little squiggly brackets there, that's kind of like the extended version of what I've got in the box. We mean the same thing. The sum of my y's divided by n is my y bar. That's the mean of my y's. And the sum of my x's divided by n is my x bar. That's my x's. So whichever one you want to look at, I usually use the first one. Okay. Okay, good. All right. So let's do one of these. All right, so we've got hours spent studying and test scores, and we want to get the equation for the regression line. So first thing I'm going to do is take all my x's and y's, and I'm just going to write them vertical here. 4, 5, 5, 5, 6, 7, 8, and then 40, 51, 64, 69, 73, 75, 93, 90, 95. Okay. Now my favorite part. Everything in it. Oh, what's our n for this problem? 1, 2, 3, 4, 5, 6, 7, 8. 9 pairs of points. That is 9. Okay. X's times y's. So that's going to be 0, 102, 256, 345, 365, 375, 558, 630, and 760. Okay. And then all of my x's squared, 0, 4, 16, 25, 25, 25, 36, 49, and 64. And if I were calculating r, I'd also include that y squared column. We just don't need it for this problem. Okay, so now at the bottom, we're going to sum each of these up, which is the part I didn't do right the other day. So let's cross our fingers here. All right. I got 42. 650. 3,391. And 244. Okay. All right. And then to the side for B, we're ultimately going to need X bar and Y bar. So I would just do that at this point now. X bar is the sum of your X's divided by N, and you already have most of that here. The sum of my X's is 42 over N is 9, and I would just leave it like that. I wouldn't worry about rounding it because you're going to plug it into a formula anyway, so the fraction's fine. Same thing with Y bar, sum of my Y's divided by N, which would be 650 over 9. Okay. So that's the part that takes a minute. Any questions with any of that? Okay. So now, on your next slide, putting all this information together. So again, those are the same formulas. We're just plugging it all in. So N is 9. Sum of X times Y was 3,391 minus the sum of my X's times the sum of my Y's, 42 and 650. Okay, on the bottom, 9 again. Now this is sum of X squared. If you want to put that whole summation in parentheses, you can. So that's our X squared column all added up, which is the one we haven't used yet, 244. Minus the sum of my X's, 42 squared. So what you see in the denominator, that's what was under the square root just for the X variable in our correlation formula. All right, and then type the top in, type the bottom in, divide last. On top, I get 3,219. On the bottom, I get 432. That's an exact answer. We're going to round to 3 decimal places here. I get 7.451 is my slope. Okay. Then to get the y-intercept, my b, you can just plug in y bar, which was 650 over 9, which you can pretty much do the same thing to the right there too if you wanted to use that one, minus my slope. I'm actually just going to use the exact fraction I had, so nothing really here has to be rounded until the end, times my x bar, which was 42 over 9. And then just type that whole thing in. So let's see, 650 over 9 minus 2 plus 42 over 9. I get to 3 decimal places 37.449. Okay, so final answer is y hat equals mx plus b, and you're filling in the m and the b when you do this. So y hat, which is a sample y we can use to find for this with this equation, 7.451x plus 37.449. And then remember, if you want to check this, you can do the same thing that we did in the last lesson. You can put your data in L1 and L2, and you can use the linear regression number 4, and it'll spit out the slope and y-intercept for you. Actually, we might do that in a minute so we can see what it looks like graphed. Okay, any questions? Finding line of regression. Great. Okay. Oh, let's use the calculator to check it. Actually, let's get the graph as well, real quick. There's a helpful little thing that'll put this directly in y equals for you, so you don't have to type the whole thing in by yourself. All right, so go to stat edit. Let's start putting it in there. All my data. Let me go back. Okay, so I had 0, 2, 4, 5, 5, 5, 6, 7, 8. Then 40, 51, 64, 69, 73, 70. Why is that not typed? Oh, shoot. Let me go over. Come on. Let's try it again. Come on. Okay. Stat, edit, then go over to calc. Number 4 should still say list 1 and list 2, and then this is where we're going to add something. We want the calculator to put this directly in y equals for us so we can see a picture of it. If you hit vars, which is right below your arrows, go over to where it says y vars, and then function is what we're graphing always. You can pick a y1, y2, all the way through y0 that you want it to insert. So usually we just pick y1. So I'm going to hit enter over y1. So it says store regression equation in y1. So again, that was vars. One more time. Then y vars. We go to the right. And then hit enter where it says function and enter where it says y1. Okay. Oh yeah, you got to set up the linear regression first to get to this. Okay, so to get this screen, you're going to hit stat. And then go over to calc, and then number 4, linear regression. And then go down to where it says store regression equation. And then we're going to hit y vars, or vars, right below your arrows. There you go.
Oh, no, you're on the right slide.
Well, I wasn't gonna pick one.
Oh,
So it's
okay.
fine.
Got it, sorry. Okay, yeah,
It's
it's
just
just
a
bars.
bar.
Oh, five bars? Yeah. Hit stat.
The way my hands are.
5.
I don't know.
Now it should be back. All right, everybody okay?
Got it? Okay, so let me calculate it. And we can check our answers. Looks like we did pretty good this time. We also have an R value. If you want to interpret that, you could do that all at once. So what does that R value tell us? Strong, positive, linear correlation. Likely it's significant because it's pretty close to 1. We could compare it to that number on our chart to see that. Okay, graphing the regression line, really easy with the calculator now. Go to y equals, and you should already have the entire equation with every single decimal point put in there for you. So that's what storing that y1 in there did for us. If not, you could just type it in on your own, just give it a few decimal places. And then don't forget, we're going to hit zoom 9. You have to do that every time because it zooms in on the particular window that you're graphing for your data. And then we get a really nice picture of that. Okay. It didn't put it in there?
Okay.
Yeah, I'll go to my seat for my water bottle.
Just say enter over equals.
Oh, because it's not.
Yeah, it's not. Like polar mode, right? From last year, probably.
Polar mode.
Here we go, it's back. Zoom 9.
Oh, thank you.
That is the line of best. So y equals, you're plotting.
She ate the whole thing and that's it.
Now.
That's.
I'm making potatoes. Okay, so we're gonna go into stat plot. We're just gonna change the type back to a scatter plot. Now let's try that.
I'll just wait for it to come off.
Well, you figured out how to.
Wait,
use
what?
it there. Yeah.
Uh-huh.
Okay, go to y equals. You need your plot to be on. So go up to plot and enter, and now try zoom 9. It's gotta be zoom 9, because you gotta zoom in on the data. You might get lucky to see it now without that, you gotta do that right, yeah.
Okay, good? Okay, so remember, plot on, zoom stat. Those are the 2 things you need. And this guy you can find under vars if you need to make a note to self. Okay. All right, what else do we have to do here? Use your model to estimate the test score of a student that studies for 9 hours. All you're doing is plugging 9 in for X for that. So again, I'm going to give it 3 decimal places plus 37.449. And you could do estimates the other way also. You could say, if I want this particular test score, how long would I have to study? So you can plug in numbers for Y and solve for an X. So it looks like they get 104.508% is their score. If you studied for 9 hours. It does look a little like math. Yep. Okay. A student that studied for 9 hours actually got a 96 on the test. Calculate and interpret the residual. Okay, so then the residual is always observed minus predicted. So observed is what actually happened. They actually got a 96. Predicted is what our equation said would happen. I'm just going to round it to 104.5. Okay, so our residual is negative 8.5. And that means our test score was 8.5, in this case, % under the prediction. Okay, and that's because it's negative. If it was positive, it would be over. Questions on any of that? Using the equation, interpreting it, seeing the nice picture, all the things we can do with it.
Okay. O2 equals. So if you want the equation in there, we're going to start getting into the equation again. Or we're going to go to this. Store. No, don't hit enter. You need that menu. 4. Go down where it says store regression equation. Okay, that's where we're going to hit bars. Y bars. 3. Okay, so now calculate it. It'll look the same. But you go to Y equals. And now just do 9.
Okay. All right. Okay. Last tiny little topic. Actually, this topic is in 9.1. I think it might be in your 9.1 Math Excel you guys are finishing tonight. Okay, so correlation versus causation. Correlation is when one thing directly affects the other thing. Causation is when we look at a graph and it looks like two variables have a relationship with each other, and they might, but it doesn't mean one is necessarily causing the other to change. There could be like this third factor mixed in that could be making both things change simultaneously. For example, eating ice cream does not cause you to get sunburned, or getting sunburned does not cause you to eat more ice cream. But we might see if we graph these that the more people that are sunburned, the higher the sales in ice cream, for example. And that's because there's this third factor, right? It's summertime, it's hot, and during that time, more people get sunburned and more people eat ice cream, and therefore if we graph these two, there could be a relationship between them, okay? So this is an example of causation, not correlation. Something is causing them both to change, but these two really don't affect one another. Does that make sense? Okay, so an example, we'll do the first one together here at the bottom. The two variables below are shown to have a correlation, but not a cause-effect relationship. And we're trying to give one possible explanation for why we see a correlation between the two. Okay, so we're comparing home value to a lifespan. Okay, so maybe we graph home value on the x-axis and we graph lifespan on the y-axis, and we see all these dots that go up from left to right. So it looks like there's this positive correlation. Doesn't necessarily mean the value of your home increases your lifespan. What is a third factor that could cause both of those to increase simultaneously?
I don't think that was good, but like having more money being like paid.
Yes, being more affluent would cause you to have a higher value in your home. It would also cause you to have maybe better health insurance and better health care, and therefore a longer lifespan. Make sense? Okay, so the last 3 problems are yours to discuss with your friends. See if you can find a reason that there could be a relationship. And when we say relationship, both could increase at the same time, or one could go up and the other could go down. It could be a negative correlation. So you're discussing amongst yourselves, and then we're going to share out. With your homework? Oh, your calculator. Yep, give me 1 sec. Let me pause it. Side rates. Okay, explain. Yes.
So if like you can't eat ice cream, you're gonna get mad.
Uh-huh.
You might feel murdered. You might feel murdered.
Yeah, so ice cream sales go down,
And then
but homicide rates go up. Yes.
From
Lactose intolerance. Got it. Uh-huh.
said the more ice cream sales, the lower like homicide rates are. Because summer is like a positive season.
People are happy.
Yeah.
Oh, she looked at it in a
Absolutely.
Yeah.
That's
nice.
Hello.
Ice cream sales and homicide rates, there's a correlation.
What is it? What is it? The lactose intolerance?
Lactose
Is it
intolerance.
normally ice
sales go
cream,
down.
ice cream sales go up when it's really hot out, If it's really hot out, murder rates are
Higher. Oh.
Did
Yes.
you make, but that's correlation, not
higher.
cause.
That's what I said, that's a correlation, it's not a cause and effect. Okay.
I thought family ratings were 5.
It's different than the second.
Because
It's one of those two.
being on your period
That's what
really
I
gets
That's
That's
what
All right, I'll get them from you. Okay, alcohol abuse and tobacco abuse. Any thoughts for the second one? Influence. Yes, people that are easily influenced. People that have addictive personalities, perhaps. Right? Okay, this is my favorite one. Marriage rate in Kentucky and number of deaths caused by falling out of a fishing boat.
marriage on a boat.
Marriage on a boat. Lots of people in Kentucky get married on boats, obviously. And yes,
More people get married and they become dads, and dads always go fishing.
true.
And
They need to get away for a little bit, have a little alone time on the lake, and there we go. Got it. What was Lindsay's?
It doesn't really make sense. I was saying that there's a Super Bowl and the Kentucky team, if there is one, they won the Super Bowl. So more people got married. But the other team that lost, more people went fishing and then they accidentally won.
All in Kentucky.
Yeah.
Look, there is really no wrong answer for these as long as you can justify your answer. Okay. All right. That's it. Any questions for me? Okay. So you guys have 9-1 that's due tonight, Math Excel. 9-2 is due on Friday, and that's the last of the new content for this week. So you guys have 15, 20 minutes now. I'll answer questions if you guys have them on your projects or Math Excel. Tomorrow, we're going to start working on a quiz in class. It is a take-home quiz, so it's not like you have to work with the partner or anything, but you can work together on it. If you want to, you'll be able to take it home on Thursday and finish it up if you need to. So that is it. Okay. All right. Go ahead and get started. I'll do cell phone lotto. 26. So buddy.
I think that's my birthday.
Happy birthday.
That's what I was.
I think I should go.
Happy birthday.
It's mad, it's clear.